Hello everyone, I'm Daniil Kirychenko and I'm from Ukraine. The project on improving the efficiency of coagulation treatment of surface water is presented to your attention. During the treatment of surface water for the needs of centralized water supply system is purification, decolorization, and compliance with sanitary requirements are supposed to be done. Reagents called coagulants are used to remove coarse and colloidal mineral impurities from water, as well as significant part of organic and microbiological contaminants. Adding coagulants to the processed water creates conditions for the enlargement of suspended and colloidal particles as a result of their interaction and integration into aggregates. Dissolved organic impurities and other contaminants are sorbed on the surface of the formed flakes, which makes it possible to improve water quality on a number of indicators. The most common coagulant used in water treatment plants of settlements is aluminum sulfate, which provides a fairly stable performance of treated water at low operating costs. At the same time, aluminum sulfate has a weak coagulating ability at low temperatures and alkalinity of water, which leads to its overconsumption in winter and during floods. New coagulants, aluminum oxychloриdes, are gaining popularity, which have certain advantages over aluminum sulfate. The aim of the project is to evaluate the effectiveness of the use of coagulants of aluminum sulfate and aluminum oxychloride to purify water. During the experimental part, the efficiency of application of coagulants for water purification by photocalorimetric method of determination of concentration of substance, which is based on measurement of intensity of a light stream which has passed through the painted solution was investigated. A single beam photoelectric calorimeter was used for this purpose. The principle of the study is to measure the ratio of two light fluxes, total one and the one that passed through the measured medium. To do this, a selected cuvette with distillated water and a cuvette with rest water were installed in the cuvette compartment. Light fluxes were uh, ultimately directed to the photodetector and the optical density was determined. And then the content of suspended impurities in the water was determined according to the calibration curve. Determination of turbidity was performed under the condition of correlation of the one nephelometric unit of turbidity to 0.58 milligrams over decimeter cubed of concentration of suspended impurities. To study the effectiveness of water purification when using coagulants of aluminum sulfate and aluminum oxychloride, the turbidity of purified water was determined using different coagulants. At the same time, the size and density of formed flakes were observed. The chart data on slide 7 shows that the larger and denser flakes are formed when using aluminum polyoxychloride. According to the graph on the slide 8, we can conclude that the use of aluminum polyoxychloride achieves greater effect of water purification. It shows experiment from 2 to 6. Almost the same purification effect is achieved in experiment 2 with aluminum sulfate at the dose of 40 milligrams over decimeter cubed, and in experiment 4 with the aluminum polyoxychloride, but a half the dose. The experiment 5 and 6 shows the feasibility of simultaneous use of the two coagulants, which allows to reduce the economic indicators due to the relatively high cost of aluminum polyoxychloride. During the experiment to determine the relative fractional composition of particles of different size in the suspension, the sedimentation analysis was performed. The principle of which was to measure the sedimentation rate of particles of the dispersed phase. the hydraulic size of the dispersed impurities. To do this, samples were taken from the scientists every 10 minutes and turbidity was determined by photocalorimetric method, and then the hydraulic size of the impurities was calculated. According to the obtained data, the suspended sedimentation curve and the graph of the dependence of clarification effect on the hydraulic size have been drawn. The suspension sedimentation curve allows us to make conclusions about the distribution of impurities by size and the time of their sedimentation. Using the graph of the dependence of the clarification effect on the hydraulic size, modeling of the settling process can be carried out. That is, according to the laboratory data, parameters of the settling tank can be determined, which is designed for real construction conditions. For calculating and designing of settlers, it is necessary to know not the size of impurities, but their hydraulic size. That is sedimentation rate. The sedimentation of suspension A, which fell at the rate of 1.2 millimeters per second, and suspension B, which fell at the rate of 0.2 millimeters per second, is characterized. The first indicator corresponds to the residence time of water in the settling tank for 1 hour. The second one for 6 hours, provided that the depth of the settling tank equals 4 meters. This technique allows to compare the ability of different waters to be clarified. Those in the laboratory conditions, the advantages of using aluminum polysaccharide purity on in conjunction with traditionally used aluminum sulfate for improvement of efficiency of coagulation treatment of water or surface sources have been given. It has been provided that using aluminum polysaccharide, either a greater effect of water clarification is achieved, or it is possible to reduce the treatment time of water to achieve the given clarification effect, or it's possible to introduce smaller dose of reagent. The other conclusions have been given on the slide. Thank you for attention.